Boats and streams, section 1. Now let's look at few of the terminologies that are like the essence of this topic, and there are two of them. One, upstream, two, downstream. In the upstream, the boat's movement will be opposite to that of the stream's movement, and whereas in downstream, the motion will be in the same direction, and this causes the velocities of the boat vary a lot with respect to ground. And we're going to study how much it is that it varies, and to do that, let's assume the velocities of the boat and stream to be some x and y with respect to ground. So in case 1, when both are moving in opposite direction, the velocity that the boat seems to move will be the minus of x and y, and in the case 2, it will be the addition of x and y. Okay, now let's move to section 2, problem 1. A man can row 18 kilometers per hour in still water. It takes him twice as long to row up as to row down the river. Find the rate of stream. Let's say in upstream his velocity is x, then his downstream velocity will be 3x, and we might know how to find his velocity in still water. It's to add both the upstream and downstream velocities together. So we know his velocity in terms of downstream and upstream. We also know that it's 18 from the equation. So with this relation, we can solve for x, and upon getting, we find the stream velocity by subtracting the downstream with upstream. Problem 2. In a stream running at 2 km per hour, a motorboat goes 6 km upstream and come back again to the starting point in 33 minutes. Find the speed of the motorboat in still water. Step 1. Laying out the picture. We know that the stream velocity, and we know the distance and the time took by the journey. Now with all of this, we got to find the speed of the boat in still water, and let's say it's x kilometers per hour. Then the downstream and upstream velocities will be x plus 2 and x minus 2. Step 2. Find the relation and solve. The total time is comprised of 2 stages, each one taking its own time. So the time took by each stage when added up must be equal to total time. And upon solving this by breaking the time into its constituent halves, we can answer the question. So go on, give it a try. And if you're new to this series, please look in the description. There will be a playlist containing all the videos in this series for you to follow along.